Hi everyone, welcome back to my channel. Today I'll be diving into WebAssembly in front-end development, especially in React. First thing first, what exactly is WebAssembly? So it is a low-level assembly-like language with a compact binary format that runs with near-native performance on the web. In simpler terms, it allows us to run code written in languages like C, C++, or Rust directly in the browser. So how this WebAssembly works? So when we write code in languages like C++, Rust or others, we need to use a compiler to generate WebAssembly bytecode. This bytecode is then executed by the WebAssembly engine in the browser and provides a runtime environment for high performance code execution. Now let's see how we can integrate WebAssembly into a front-end application. Here I will go with a React application. So to get started with WebAssembly in React, we need to set up a basic React app. Here I have already created a React app using Create React App. You may use Webpack to set up your application. Here at first I will create a simple C++ program that takes two numbers as arguments and returns the result. Now in the root directory of this project, I will create one folder that is CPP, and under this cpp folder I will create one file that is error.cpp. In this file I'm going to write my program. So I will write extern c, and within it I will write one function that is error. Now this function returns integer value, and it takes two variables as arguments and returns the addition of those two variables. Here the extern C has been used to declare a function or variable with C linkage. Now to compile this CPP file, I will use the SDK that is mscripten. Even if you look for the WebAssembly documentation on MDN portal, it recommends you to use mscripten. Now from this guide you can set up mscripten compiler in your system. I already have it in my system, so I'm not going to install it again. And you can check if your system has mscripten or not with emcc-v. It will show the version of mscripten installed in your system. Okay, now I have mscripten in my system, and I have to modify this file with the mscripten library. So I will include nscripten.h, and then I will use one macro that is mscripten keep alive. Now without this macro, the compiler could potentially optimize away the function if it believes the function is not being used. Okay, now I will create a bash file that will help me to compile this file quickly. So I will create one file that is make.sh, and inside this file I will need some variables. So the first variable will be module name, and the value of this module name will be the path of the error cpp file. Now the next variable is output.js. Now the value of this output.js variable will be the path of the generated WASM file. So WASM files are nothing but the WebAssembly generated files. So this file is JS, and the next file will be the WASM file. So the variable name is output WASM, and directory or the path will be ssc WASM, and under that it will be added wasm.wasm. Now the command name for mscripten is emcc. So I'll write that, and then I'll give the module name that is cpp adder, that the variable is available above dot cpp. And in the next line as output flag, I will give the value output.js. So the variable will be output.js, and in the next line I will export the JS as ES6. So I'm giving the value as 1. Okay, now in the next line I have to give the export name, and the value will be module name. The module name is already available above. And in the next line, again, the source of this environment uh, flag will be web. The value will be web. Okay, now as per my shell script, the output will be generated under wasm directory. So I have to create that under SSC. Okay, now I'll go to my terminal and run this bash script. So I'll write bash make.sh, the script file name. So there is no error. Now I'll go to this code editor and expand this wasm folder. And here you see that two files have been generated. So this first file adder underscore wasm.js. So it is a JavaScript wrapper that helps loading the WebAssembly module. Now the second one is adder wasm.wasm. Now this wasm file is actually the WebAssembly binary file. Now I'm coming into my React application. So inside this app component, I need to first delete everything from here, and I'm writing RAFC that will create a snippet for React arrow functional component. And in this component, I will create two input fields and a button, and I will show the addition of those inputs on that button click with the help of WebAssembly. So here I need two input fields. So I'm writing that. So the input type will be number, and again I need other input field. Then I will give one line break, and then I will show the result of that. So here I'm just showing the result as text, and later I will give the actual result variable. Now to keep tracking of those input values, I need to use some local state, right? Now on change of these input variables or input values, I will update the state. So here I'm using numbers as state and using useState hook. So the value of those numbers or fields are A and B. So on change, I'm just updating the state. So the first number will be A, and on change of the first input field, the value of A will be changed, and the second input field, the value of B will be changed. Now there will be one button, and on click on this button, I will call one function that is handle click. And on handle click, I need to calculate the addition of those two numbers and update the state. Now I need to maintain another state, that is result, to store the addition. Now I'm using useState and keeping the default value as 0. Okay, now I'm going to consume the WebAssembly. So first I will consume the WebAssembly wrapper. The wrapper is nothing but the JS file. So I'm importing as WebAssembly wrapper from added.wasm.js, and then I will import the binary file. So I'm writing WebAssembly binary, and I'm importing from that wasm file. So this binary file is nothing but that wasm file. Okay, now I have to create the instance of the wasm module. So I'm naming it as wasm module instance and using this WebAssembly wrapper to take help to create the instance. And here I'm just returning the WebAssembly binary. Okay, now I'm good to use this wasm module instance. Okay, now in this handle click method, I will write wasm module instance dot then. This wasm module instance returns a promise, and here I will get code, and I'm writing const res equals to code dot adder. Adder is the function name, and I have to pass the two numbers. So the first number will be numbers dot a, and the second number will be numbers dot b. And finally, I'm updating the state with res variable. Now I have the result in my result state. Now I'll use that to render the result. Okay, now I'm good with my changes, and now I will go to the terminal and run my React application. Here I will type npm start. It will start the React app. So here you see that the React app is running at port 3000. Now I'm going to the browser and giving two numbers as input, and if I click on this submit, you can see the result. So here we are leveraging a C++ function to perform this addition with the help of WebAssembly. Now let's talk about the use cases of WebAssembly and when and why you should use this. Okay, we can enhance the performance of web applications by offloading the tasks to WebAssembly, which are more CPU or RAM intensive. WebAssembly is a game changer for high performance games on the web we play nowadays. Also, online image and video editing performances can be boosted using WebAssembly. So, all of these are possible because WebAssembly generates a bytecode that is more closer to the processor. So, with the help of WebAssembly virtual machine, the assembly level bytecode is converted to the machine level code, and then that machine level code can be executed by the processor more quickly. So for those use cases, you can absolutely consider using WebAssembly when building your front-end application. So that's all for today. I hope you enjoyed this session. Don't forget to hit the like button and subscribe to this channel for more such videos. Thank you.